continuing with the nonmetals, and we're going to finish up with oxygen. There are some peroxides and what they call superoxides. Peroxide you probably heard of before, like hydrogen peroxide. Hydrogen peroxide is H2O2, and oxygen changes its oxidation to -1 instead of -2, which is not a normal thing, but it can happen, okay? Hydrogen peroxide is very, very reactive. It's like disproportionate because of that, changing the oxidations number. So it's itself is oxidizing and reducing, but what it's really used for, it's very antiseptic and it can bleach fabrics, okay? We know that it's very good at cleaning up boo-boos, right? The superoxide ion, which is O2, it's formed with most active metals like potassium, rubidium, cesium. And then there's the superoxide also react with water to produce O2 in a breathing apparatus. And you can see it here with the firemen. They count on that to give them extra. Okay. Other group 6 elements, that would be, we talked about oxygen. We have sulfur, selenium, beryllium, and palladium. Okay. They have an oxidation of -2, but they can change. They can go to +4, +6. It just depends on. Their d orbitals, the orbitals that are right before that in the transition, can expand. So they cause the electrons to kind of jump around. And you can see down here, it shows you, again, how much they get bigger, their radius gets larger, and so on, their oxidation or the ionization. Oxygen's the highest because usually the smaller ones have the higher oxidation, and so on. But again, sulfur of all those would probably be used. Selenium is used as well. It's an important mineral in the soil, okay? And with palladium, the very bottom one, it has no stable isotopes. It's kind of weird because most elements, like even hydrogen has 3 isotopes. Palladium only has 1. I mean, 1 form. It doesn't have any isotopes. So selenium and beryllium, these are anions, and you get them from minerals. You'll see them usually with copper and lead. Selenium is kind of different because it doesn't conduct electricity in the dark, but it will in the light. So it can be used in photocells. It's used in light meters, photocopiers, because it will, if you light something up, then it's exposed to it, and then you can actually see it. But in the dark, it won't. Okay. Sulfur, the elemental form of sulfur is yellow. It's a solid. It consists of rings of 8. So actually, when you're looking at elemental sulfur, it's S8. Okay. It can be found in many minerals. You have sulfide, sulfate, phyte. There's all kinds. Okay. One problem with the appearance of sulfur in nature, it's usually an impurity in coal, and when you burn it, it combines with water in the air, and then you get acid rain because you produce sulfur oxides. They call them SOx, SOX. Okay, when you burn them, so that can be a problem. The coal in North Dakota is pretty good, doesn't have a lot, but they're going to test the coal, and if it has too much sulfur in it, they won't burn it. Okay, uses of sulfur. We use probably the most common, or the thing that we use the most, is sulfuric acid, H2SO4. It's the most commonly used, or the most important industrial compound used. It's a very strong acid, so it's an oxidizing agent and a dehydrating agent. It's the most produced of any of acids is sulfuric acid. They use it in the manufacture of rubber too, to get the sulfur to stick together and produce rubber. If you've ever done this, I don't know if you've ever done it, but if you take table sugar and you add sulfuric acid to it, it dehydrates it to the point that it grows kind of like in the summer when you light black snakes, you know how they grow up? It'll do that, but it stinks to high heaven because sulfur gas is awful, sewer gas. Sulfides and disulfides. Sulfur is a -2 oxidation, like oxygen. Hydrogen sulfide and organics, like I said, very unpleasant. If you smell rotten eggs, that's disulfide, which is a sulfur component. You'll find it's a natural part of gas. They actually, if you have propane doesn't have a smell. Well, obviously you don't want propane leaking because it'd be very explosive. So they put that smell, dimethyl sulfide, into natural gas, into propane, so that you can actually smell it. And it's not a pleasant smell. So you want to get, you want it taken care of. So they do add nasty smells to propane and natural gas because you can't smell them naturally. And you really want to. It's a safety precaution. Okay. There's a lot of minerals that have sulfur in them. Galena is one. It's real pretty. Cinnabar. You'll see pictures of them on the bottom. They have, so you have mercury and lead and sulfur. Pyrites, which would be fool's gold if you've ever heard of that. Found in minerals like iron pyrite, again, which is fool's gold. A lot of people got it and they, oh, I found gold. And oh, no, you didn't. It's not worth a whole lot. But it looks like gold. It's real pretty. But those are sulfur compounds, okay? Again, the most important of all sulfur compounds is sulfuric acid. All right, it is like it. There's bisulfides that are used in toilet bowl cleaners. They use them to adjust pH in swimming pools and hot tubs. SO2, sulfur dioxide, is poisonous, especially lower organisms. So like in like Yellowstone, where they have the hot springs, there's only certain things that can grow in there because of that SO2. Sulfites and bisulfites can be used in foods and wines to kill bacteria, but people can be allergic to it too, especially people that are have asthma. So they have to be careful, read the labels. If you don't have asthma, it probably won't bother you. Okay. There's a thing with sulfur, you'll see thiosulfates, thiocyanate, something like that. They use that. It means that sulfur has replaced oxygen. So the thiosulfate ion is S2O3 and it has a -2 charge. Get out of here. Go on. Get. One sulfur atom can replace one oxygen in sulfate. So you can see here's sulfate, SO4. Here's thiosulfate. It's 2 S's and 3 oxygens. It replaces them. Hey, get out of here. Go get. Sorry, you guys. My dogs are being obnoxious. They got their bark box today. Okay, thios in biology. Thios, when you take that sulfur-sulfur bond, you can see here it's used in like permanents. Okay. All right, I'm quitting. Oh, I had to take a little break there. My dogs were getting a little obnoxious. Anyway, when you're talking about sulfur-sulfur bonds, you can see curly hair versus straight hair. They join up together. You know, this can be reversed and broken. It's important in protein chemistry, those sulfur-sulfur bonds. We've got nitrogen, which is also in that group, or is the next group over. This is 5A. Okay, nitrogen is at the top, and then you have it below. 78% of the Earth's atmosphere is nitrogen. Most people think the Earth's atmosphere is mostly oxygen, but that's not true. Nitrogen is number one. Okay, where does it come from? It comes from nitrate salts. It comes from distilling liquid air. You can see over here some of the nitrogen compounds. Big one right there, ammonia. It's used for a lot of things. The thing with nitrogens, it's colorless, it's odorless, it's tasteless. It has an extremely low melting point and boiling point. So that's why it's a gas at room temperature. Okay. It forms a triple bond. Okay, so it's very unreactive. Okay, oxygen forms a double bond, so it's kind of reactive, but nitrogen's even stronger because triple bond, that would be more energy to break that bond. So it's very inert. In other words, it doesn't react. Once you get N2, it doesn't react very much. Okay, and again, the most important use of nitrogen is in fertilizers. Okay, it would be great if we could take the nitrogen from air and use it, but we have to do things from it because it's very, very, very stable. Okay. Usually nitrogen's -3, but it can also be +5 depending on what it's combined with. Okay, so nitrogen is converted to ammonia. That's called the Haber process. One of the most common things, one of the top things that happens in industry is to take nitrogen and hydrogen gas and make ammonia. Ammonia is used a lot in fertilizers. I'm sure you guys have been stuck behind one of those little white tanks. It'll happen soon this spring when the farmers are putting the ammonia on their fields. Okay. Ammonia reacts with what they call hypochlorite to produce hydrazine, and it can be a very strong reducing agent. If you have methyl hydrazine, it's a rocket fuel. Okay, so there's all kinds of things you can do. Ammonia is converted by nitrogen oxide and nitrogen monoxide by what they call the Ostwald process. It's a reaction in oxygen at high temperature, and the catalyst is platinum. This can happen. You can also have NO produced or changed in your car, in your catalytic converter, because you have a little piece of platinum in there, but it's not ammonia. It's a way of adding more oxygen. So instead of getting carbon monoxide, you get carbon dioxide, getting rid of the poisonous stuff and getting the not so poisonous stuff. Okay. Nitrogen oxides, laughing gas. I don't know. I've never had it, but if some of you guys have been to the dentist and had laughing gas, it's a general anesthetic, and it's no harm. The pain is lessened and you giggle, they say a lot. That's why they call it laughing gas. It can be used in an aerosol because they had to replace the CFCs, the chlorofluorohydrocarbons, because of their detrimental effect on ozone. So now they use aerosols with nitrogen gas. The whipped cream is one. Nitric acid is it can be slightly toxic. If you use it, you guys, you got to be careful because I've had my fingernails turn kind of a lovely orangish color because of it. It can cause problems with your lungs, vasodilation in your lungs. In other words, they close up a little bit, especially people that are more susceptible to it. If you remember when you talked about the London fog, there was nitrous oxide was one of the bad things in the air that caused people to die from breathing issues. Okay, NO reacts with oxygen in the air to produce nitrogen dioxide, which again is the pollutant found in smog. So again, we talked about that before already. If you remember the London fog video. Okay, smog is not a good thing. Usually it starts from the pollutants from your car, and then you have to have certain conditions with the atmosphere, and then you'll get smog. And if you breathe it in, it's bad for your respiratory system. It's hard on your eyes. It's just not a good thing. Okay, so when we have nitrogen, we can have oxyl acids like nitric acid. Like I said, very strong oxidizing. It's used in fertilizers. You can use nitric acid in TNT, which is dynamite. Okay, they also have nitroglycerin, little tablets that people take when they're having heart issues. You'll hear people sometimes taking their nitro. What happens is it's a vasodilator. In other words, it opens up their tubes so it's easier for them to breathe, and it's easier for them to get blood into their vessels will open up more. So then it'll take away the pain in their heart. Okay, it's very important industrial compound though, nitric acid. There's nitrous acid, you can see is one less oxygen. It's less stable. It's a much weaker acid, not used as much, but it has a few purposes. And you can see the structure of them on the side there. But nitric acid is a very strong oxidizer and is used a lot in industry. Okay. Other group 5 elements, besides nitrogen, we have phosphorus, we have arsenic. That used to be the favorite way for women to poison their husbands. Antimony, and we have bismuth. Okay. And again, their size and metallic character increase as you go down. This is the most metallic. These guys are actually considered metalloids, and then you have your nonmetals. So this group has all of them. It's a very diverse group. Nitrogen is diatomic. All the others are single bonds, and they can form more than that if they need to, but the only diatomic one on that list is nitrogen. Okay, and again, you can see the properties is not a big deal. You can look at these up. Okay, and again, the oxidation, -3 to +5, depending on what they're combined with. Okay, phosphorus, the main source of phosphorus comes from minerals. There's 2 types of phosphorus. There's white phosphorus and there's red phosphorus. Okay, the white phosphorus is P4, so 4 phosphorus together. It's formed by taking calcium phosphate and carbon, and you go through a reaction again with silicon dioxide. They use it in furnaces. It can burst into flames if exposed to oxygen, so it can be very, very, very explosive. Red phosphorus, which is produced by heating white phosphorus to a high temperature in the absence of air, is more stable. You'll hear sometimes about white phosphorus in bombs, especially in Vietnam. They're not good. People that were burned severely, because if they're exposed to oxygen and air, well, they shoot out these bombs, and that's when they get exposed, when they hit people, and it's just not a good thing, you guys. Okay. There's phosphorus haloids. In other words, phosphorus and the halogens, chlorine, bromine, iodine. They're used commercially. A lot of times they like to make soap or detergents, some insecticides, some plastics. I would say soaps and detergents would be probably the number one, PCl3. You have, do we have any more? Oh, that's the only one. Okay. So that's some of the uses of halides with phosphorus. We have oxyl, which again, when we take oxygen and phosphorus, we have phosphorus 3 oxide, P4O6. We have phosphorus 5 oxide. We have anhydrous. So we have all kinds of things. Of those ones, the one you probably know the most is phosphoric acid. That's used like in pop. It's a flavor agent. Okay. Phosphoric acid is also used in fertilizers. It can be used in detergents, used in water softeners, and to get it, you take polyphosphates and you dehydrate them. In other words, you remove the water, and then you get your phosphate groups. Okay. So we're just about out of time. So we'll quit there with the phosphates. But again, phosphates are used a lot in detergents and as flavorings. Like I said, if you drink pop, you've drank phosphoric acid.